This is our third video. It is going to be focusing on the application of trigonometric ratios, specifically finding missing side. So the last video, we were focusing on constructing that trig ratio for sine, cosine, and tangent. Now we're going to utilize that trig ratio property to find missing sides. Okay? So if we look right here, again, in this diagram, are there any angles shown? Yes, we are going to be using trigonometric ratios because we will be using angles. We are not looking for missing angles. We are looking for the missing side. So we're going to utilize the trigonometric ratios that we constructed in the last video. Okay. Again, sine of angle, this is an angle, theta is equal to the opposite side over the hypotenuse. Cosine of theta is equal to the adjacent over the hypotenuse. And tangent of angle theta is opposite over adjacent. Let's dive into how we can utilize trig ratios to find missing sides. Kind of follows this process. Label our right triangles. We're an expert at that because in the last video we literally went to Ignatium to construct them, so we know how to label. We are then going to identify which trig ratio to construct given the values that we are presented. Okay, so identify which trig ratio to construct by the given values. Step 3, construct the trig ratio. So after we figure out which one we're going to do, we're going to construct it and solve for the missing side length. Let's take a look at what this would look like in some examples. So what we need to do is find FG. So this is the one that we're looking for, FG. What side is that? It's literally this side right here. This is FG. Okay? So we're looking for that one. What we need to do, step 1, is to label our right triangle. Well, it comes from looking at the angle that we're given. What angle are we given? Well, we're given the angle E. It is 49. So this is our angle right here. This is where we're going to label our triangle. Always, or at least what I always do, is find the hypotenuse. Look for the 90 degrees, the right angle, go to the side opposite to it, boom. This is the hypotenuse. Got it. This is my hypotenuse. That means the side opposite to my angle that I'm referring to, 49, the side opposite is going to be the opposite side. So this right here is my opposite side. That would leave us the adjacent side, the side next to or touching the 45 degrees as our adjacent. That's it. Now I've labeled my triangle. Now what I like to do is circle what information I'm given and what information I'm looking for. Remember, I'm looking for FG. This is FG right here. So I'm looking for that side length. What side length am I given? The hypotenuse, which is 4. The information I'm given, angle E, is my theta, is 49. So, which trig ratio deals with opposite and hypotenuse? So let's take a look. Which one deals with opposite and hypotenuse? Sine. So I'm going to utilize sine. So let's do that. Sine of theta is equal to the opposite side over the hypotenuse. Boom. What is my angle? Well, my angle is 49. Perfect. And what is my opposite side? Well, that's what I'm looking for. So that's FG. And then my hypotenuse is 4. Perfect. Now that I've constructed my trig ratio, I can utilize numeric solver to help us solve for this missing value FG. Okay, so this is going to be my E1, and the fraction FG over 4 is going to be my E2. But I do need to make sure one thing, that my calculator is in the right mode. So I'm dealing with degrees, right? I have 49 degrees. I need to use my calculator in degrees. So click mode, go down. Right now it's in radians, so I need to go to degrees. Boom, I am good. Now I can then go to numeric solver. So numeric solver, I'm going to put in my trig ratio. I'm going to put sine of 49, close that parentheses, and put the fraction that I have on the right-hand side. FG is my mystery, so I'm going to put that as x over 4 and be done. I'm going to put 1. Again, the only reason why I put 1 is because I want to make sure my guess is positive, and side lengths can't be 0 or negative, so 1 is a good one. Press alpha, enter, boom. Now I do need to round in this one. I need to round to, let me grab my, I need to round to the nearest tenth, which is 1 decimal place. So I need to round to 1 decimal place. So FG is equal to 3.0188 and so on. First decimal, or the 10th place, is the 0 right there. Look to the right, it is 1. So actually the approximate value is just going to be 3.0. So the length for FG is just 3. And that kind of makes sense. It should be less than 4. So we're good. So you would just enter 3.0 into IXL. Let's take a look at another example. Right here. We are looking for WX. So what side are we looking for? This one right here. That is WX. We need to label our triangle. So what side is my, or sorry, what angle am I referring to? It's this angle right here, 38. This is the angle that I'm referring to. This is my acute angle. So let's label my hypotenuse first. Look for the 90 degrees, boom. Side opposite, boom. So my WX is my hypotenuse. The side that's opposite to the 38 is WV. So it's this length, or this side right here. This is my opposite side. And the adjacent side is one left over next to the angle that I'm referring to. This is the adjacent side. So how do I know which trig ratio I need to construct? Well, it comes from what information is given to me and what information I'm looking for. What am I given? The adjacent side, 6.3. The angle, theta. What I'm looking for is WX. This side is what I'm looking for. So I really don't care about the opposite side. What trig ratio deals with adjacent and hypotenuse? Let's take a look. Which one deals with adjacent? Well, sine does not. Cosine deals with adjacent. Perfect. And it also deals with hypotenuse. So I am going to use cosine. Perfect. So, looking at my trig ratio, cosine of theta is equal to the adjacent over the hypotenuse. I just need to fill in my information. My angle for theta is 38 degrees. It is equal to my adjacent, which is 6.3. My hypotenuse is what I'm looking for. So that's WX. So there we go. I've constructed my trig ratio. So now I just need to solve for VX. Or sorry, not VX, WX. And really that's just, you can utilize numeric solver or you can solve it by hand. I'm going to use numeric solver just to keep it convenient for us. So left-hand side is E1, right-hand side is E2. Press up, up. I'm going to clear that, put cosine of 38. Again, I'm already good because you can see on the top of your calculator that the mode I'm in is degree. So I'm good. If it was in radians, I would have to change the mode. Press alpha y equals, make my fraction, 6.3, drop down. I'm going to put an x for my WX. So that's what I'm looking for. Put 1, alpha, enter. And there we go. I have WX is equal to 7.99481 and so on. Right, it keeps going. I need to round to the nearest tenth. That's the first decimal place. So I need to round this 9. So I look to the right. That 9 I have right there indicates that I have to round up. And sometimes it's a little confusing. How do I round 9 up? It goes to 10. We'll carry that 1 over, or think of it as 79. what should 79 or 7.9 round up to? It should round up to 8. 8.0. And that would mean my hypotenuse is, let me erase this for a second. My hypotenuse is, again, 8.0. And we're good. My hypotenuse is greater than my adjacent, so that is a good indicator that I am in the right direction. So here are a few examples that you can utilize to help you find missing sides. We have a few more examples, so we're going to just dive into it. But I really, again, want to emphasize before we get into the next few examples that it's just really labeling your right triangle, identifying which trig ratio to construct, right? Which out of the three should we utilize by the given information or the given values. Then we construct it and solve for the missing length. Okay, so let's utilize those 4 steps in these 2 examples. So we are looking for RS. What is RS? It is this right here. This side is RS. Now that I have kind of figured out what I'm going to do, I'm going to just label my triangle. This is step 1. So what is my angle that I'm referring to? This angle right here. This is my theta. It is 40. So that is my angle. Perfect. So time to label my triangle. Look for the 90. The side that's opposite to it, this right here, is my hypotenuse. So this is my hypotenuse. Side opposite to the angle that I'm looking at, right there, this is my opposite side. And then the last one is going to be my adjacent side, the one side that is next to. So this is my adjacent side. Okay, now that I've labeled, I just need to identify which given information is going to tell me which trig ratio I'm going to use. So I am given the adjacent side, 6. I'm given the angle 40, and what I'm looking for is RS. So I don't really care about the opposite side. So again, I'm dealing with one that is doing adjacent and hypotenuse. I've already done that. That was my second example. That's cosine. So let's quickly do that again. Cosine of theta is equal to the adjacent side over the hypotenuse. I constructed the trig ratio. Now let's substitute the values. My angle is 40 degrees. So again, theta becomes 40. The adjacent side becomes 6. And I'm looking for the hypotenuse. Perfect. Oh, my hypotenuse is RS. So I'm going to just label that as RS. There we go. I can do it by hand, or I'm just going to use numeric solver for convenience. E2. You can also use numeric solver to double check your answer. Even if you did it by hand, it's always good to have a way to double check your work. So cosine of 40, my fraction, I'm going to put this as just 6. And again, RS is my hypotenuse. That's my x, so I'm good. Press alpha, enter, and I get that the value should be, I'm going to be very quick with this. I'm going to just round it from my calculator, so I'm not going to write it down. RS is equivalent or approximate to 7.8. The number after 8 is 3, so I don't round up. I keep the 8, and there we go. So you're going to get much quicker with this. So let's take a look at the last example, just to round all our examples together so you have the best possible chance to get the highest possible grade you can get with this practice set. So here we are looking for WX, this side right here. So I'm looking for WX. Let's label my triangle. The angle that I have is 35. So this is 35. Perfect. Let's label the hypotenuse. Look for the 90. Look for the side opposite. It is this one. Length 7. Then I'm going to find the opposite side. So looking at my angle 35, what side is opposite to it? It is WX. So it's this side right here. This is my opposite. I forgot the label the hypotenuse, hypotenuse. There we go. And the last side is my adjacent. It's the side that is next to the angle. So this is my adjacent. So looking at my labeled triangle, which information is given to me? Well, I'm given 7, the hypotenuse, and my angle, theta, which is 35. What is the information I'm trying to look for? Is WX. So I'm looking for the opposite side. So there we go. I'm trying to deal with a trig ratio that deals with opposite and hypotenuse. It is not cosine anymore. It is, again, sine. So sine of theta is equal to opposite side over the hypotenuse. Sine, my angle is 35, so I'm going to put 35 here. So sine of 35 degrees is equal to opposite, which is WX, over the hypotenuse 7. Perfect. We've been here. I'm going to use numeric solver to help me find our missing value WX. So let's get into that again. Math, press up, numeric solver. I'm going to put sine of 35. My fraction, I'm going to put x on top, 7 on the bottom. Press 1, alpha, enter. And what I get is an approximate value for WX rounded to the 10th place or the first decimal. It's going to be just 4.0. So WX, the opposite side, is roughly 4.0 in length. And it should be less than 7, and it is. There we go. So in all these examples, again, what did we do? We labeled the right triangle. We identified which trig ratio to use or to construct by the given values. Okay? What information is given? What information are you looking for? Construct that trig ratio and solve for that missing side length. And you can use numeric solver or you can solve it by hand. Either one is valid. Guys, work on practice UZC and IXL. You only need to get an 80 to get the maximum score. Work through it. If you have any questions, come and reach out to me or Mr. Tolson. Otherwise, guys, I'll see you in the next video. Good luck.